Hello and welcome to another edition of Tech Deck Karaoke. I am unfortunately still your host, Joe Onisick. I am joined by my esteemed colleague, our impartial judge, Miss Sabrina Schaefer Esquire. And our guest for today is Justin Allen with ePlus. And we are super excited to have Justin on. Justin, please tell us real quick what is it you do for ePlus?
I am a director of architecture. So not only do I focus on dinosaurs, I actually am responsible for understanding a multi-architectural solution from endpoint all the way to data center.
Brilliant. All right. So big scope. And Miss Sabrina, what is it you do here?
So aside from being an impartial judge, partial, actually, that was probably a Freudian slip. My job is to really keep you in check, encourage the Joe banter, and as always, keep track of who's really doing it best. It's like a who wore it best, but for technical decks.
Brilliant. Well, I appreciate that. And for our audience at home or at work or in the car or on the toilet, most likely, can you confirm that I have never seen these slides before and we will be cold presenter in about 20 seconds? So today we're going to be talking about digital network architecture. This is a far cry from your old school analog network architecture with plain old telephone systems on copper wires running grandma's phone call to you so that you could avoid it and go out with your friends. We're going to talk through an overview of next generation networking, which is really where networking is today, but more importantly, where it's headed. And we'll probably get into a little bit of why, but I'm completely guessing on that aspect. As we look at networks, today, networks need to be far more intelligent than they were 5-10 years ago. The evolution of networking is extremely rapid. Networks today must be constantly learning, adapting, and protecting our environments. And the reason they need to be doing this in a much more automated and autonomous fashion than before, because they're moving more data, changing more connections, they're doing more faster than what we can do as humans to administer them. So our networks need to become more intelligent with the ability to absorb your intent for how that network architecture should operate, apply the context of how it's operating and what's happening in real time, tie those together to be able to create a secure autonomous network and constantly learn and evolve in that process. So as we look at this, we're creating an intent loop where the intent of my network is driven down into the deployment of the network in an intent architecture, which really falls back on ideals like promise theory, where what we want to do is manage with intent rather than directive. We want to tell the network the intent of what we're trying to accomplish and allow the specificity of configuration to be handled at a lower level, possibly a device level, either in physical or virtual devices. Then we need to be able to pull context back from this as these things change and evolve to be able to do things like secure that network, which is top of mind for everyone.
Hey, Joe, what happens if my intent was to go to the beach?
If your intent was to go to the beach and you properly built an intent network, then the chances are you'd have some more time for that because you wouldn't be on a keyboard sitting in the CLI wondering why they disabled Telnet and figuring out which SSH client to use.
Man, do you keep all those brains in that beard? Is that what's going on here?
That's where they're hiding. So when we look at intent-based networking and how it really works, we're taking an intent. And when we talk about intent, it's a high-level purpose of the network. It's going to take into account the general policies for how we want that network to operate from a connectivity, a security, an uptime, and an SLA perspective. That intent gets defined as policy, which is then going to be translated into the tools that the automation engines that are in place can use, whatever they may be, from things like Puppet and Chef to things like Terraform in the cloud to things like actual software-defined networking systems and control systems in a more private or traditional infrastructure. So that intent translates into policy, which then gets translated out to the automation systems, which activate that policy in the specific requirements of a given set of devices. And then that context is the feedback loop provided back up so that we can have an assurance that our intent is being carried out on the network. And all of this becomes a loop, right? We're looking to constantly drive that intent, modify based on context, and assure that we're getting the results in real time that we're looking for with these systems.
So Joe, you just described something that was out of Terminator. Is this like the Cyberdyne systems coming back to haunt us?
This is kind of like level 1 of Skynet. It's really the beta testing of it. Once the networks have full control, we're all completely screwed, but we're already too far past the point where we could stop it to do anything about it. So now it's time to embrace it, grab a beer, sit back and enjoy the ride.
It's face the inevitable.
And this is where that ride is headed. If we don't do this, we're going to sink our ship, because we can't move fast enough to maintain the change that's happening in our technology environments. But beautifully, to Justin's point, if we do this, our ship's also going to sink as Skynet takes over and realizes the real problem are the people.
Wow, that's actually a pretty good read. I just put this in there to kind of illustrate my career, but hey, I like your slide better. Your thoughts there.
I thought this was more an illustration of Joe's career. That's an interesting take, Justin.
It could be, depending on how much of this season. So far, he's doing pretty good. I'll give him that.
Oh, let's not get
I'm laughing about this career-wise because when I first started getting into like more sales roles, I described my sales strategy as more like a Marine Corps island hopping campaign because of all the bridges I burned. So I'm really just taking PT boats from island to island and trying to grab some ground. So when we start to take this intent system and we look at it in more specific applications, we can look at the access layer of the network, which is extremely important to the overall network. The access layer is what touches the users, devices, things, and machines that our network is built for. The access layer is where they access or attach to that network, be it wireless or wired or any combination of the two. So when we look at software-defined access and the ability to drive that connectivity down, you'd have to imagine and assume that the change rate and the diversity at the access layer is much higher than it will be at other layers of the network, because we're attaching to any number of devices of any type, attaching to different people, and those people are using different devices. So the access layer maintains a giant change rate. It has huge security concerns, and it also has a very broad level of connections. So the access layer is an ideal place to start looking at intent, where we can start to bring in higher level services that are built upon these systems. Services like identity-based policy segmentation, where we're starting with who or what you are to provide a policy for what you can talk to, narrowing our segments on the network to reduce our security exposure. So we can reduce those segments down to groups that should talk. A great example of this that's commonly used in the world of microsegmentation is to limit users from being able to communicate on the network directly to one another. Because in most cases, you don't need to be able to use your device to directly talk to Justin's device. You're usually accessing resources further along the network. So being able to utilize identity to attach to policy and then create tighter segments reduces our risk vector or our attack vector, meaning an exposure of a given device doesn't necessarily give it access to as many devices as it would have in a traditional, more open VLAN segmentation model. We can also take this a level further by automating that network fabric, being able to provide a single network fabric across a wider wireless and wired environment where we can treat the two the same from a policy perspective. And remember, when we're talking about policy, we're talking about security, but we're also talking about connectivity, uptime, quality, end user experience, all the other things that it's important for a network to deliver. And then finally, we can bring in more insights and telemetry from what our network is doing. And what we're talking about is gathering data about what's happening on the network in real time so that we can start to gain insights from that information. If we start to see a flood of unusual traffic in a given area, we know it's something that we want to take a closer look at. So as we build out these software-defined networks or intent-based networks, we can start to utilize the insights and the telemetry of data traffic to provide better network management and configuration.
Wow, that was pretty good. That was overthinking it a little bit. I would have just gone with, hey, software-defined access is intent-based policy segmentation, automated network fabric, insights, and telemetry. Next slide.
Yeah, but this is why you get paid the big.
Yeah, apparently.
I'm just here to act like I know what I'm talking about the slides, right? You get paid to know what's going on.
I want to know, when was the last time, Joe, you were accused of overthinking anything? I actually take that as a compliment. I don't know.
Literally a lifetime first.
Look, when he's not huffing paint, he's actually doing his job. So
I own tractors now, so I've moved to starting fluid. It's really much better than paint.
Better for the environment too, sustainability.
You can always go back to the good old IT source, which is the markers, the dry erase markers.
When you go to whiteboard and they're all dried out, you're like, "Are you kidding me? There's 12 here and they're all dry." Yeah.
Yep.
Mm-hmm.
One for the board, one for me.
Exactly. Yep.
So when we take this and we start to look at what one of the things we're really trying to drive in the networking world is the ability to enforce microsegmentation. Now, microsegmentation is, of course, a big fluffy buzzword that gets used in a lot of different areas, but the idea of microsegmentation is very simple. We want to create segments for the purpose of security control that are smaller and more granular over time. So the idea is we want to be as granular as is possible for your given environment. And this is really moving us away from these broad open VLAN-based networks where everything on a VLAN network segment could communicate fairly freely. Because what happens is a given device gets compromised, and then that device ends up having access to everything else on that segment. The smaller the segment, the lower the risk.
Nice.
Excellent. So we take this a step further and we start to look at the way access truly happens. Access in a given enterprise is a combination of wired and wireless access. So what we want to be able to do is normalize that access across the board. A user doesn't care if they're on wired or wireless. They want access and they want your experience. And they shouldn't have to make sacrifices between one or the other. We also shouldn't have to manage the two independently from a security and policy perspective. So what we want to do is normalize that management, administration, and deployment of policy across our wired and wireless so that we can treat them as a common access network.
Sure.
And the plot thickens.
I was going to gloss over the technical jargon here, right? Because we've got a ton of acronyms here, and I'm going to say with a lisp.
Yeah, we'll go with what you said.
We'll put a pin in that and come back in your presentation. I have a feeling. So when we really take a look at that fabric and the roles and terminology across this, we're going to get into a lot of things that I'm going to read off the slide really fast so that it sounds like I might have a single clue. We're going to start with a controller for the system. The controller for the system is the brains. It's the management. It's where I take business intent and apply it to a system that can distribute that. And in this case, we're talking about the DNA controller, or DNAC in short. We can attach to that various higher level services that add advanced functionality within that. Things like identity services and wireless networking services and analytics engines. From there, the intent is described and it's pushed to the given devices. Those given devices, depending on what type of device they are going to absorb that intent and translate it into the appropriate configuration for that device or system type. Now, the beauty of using intent in this fashion is the abstraction layer it provides. Switch 1 and switch 2 may utilize different configurations to get the same result, but they can absorb one intent, interpret that intent, and translate it into their own specific configuration.
Wow. On a scale of our universe to the next universe, that's how close you were. You were pretty darn close. I think you hit a planet somewhere along the side, but we'll keep going.
I was one universe away with only a planet level
This
rift.
close, man. You were this close, just a universe away. What is that? How many light years is that?
At least 7.
There we go. Okay.
Then we start to look at how this
descriptive on this one. Be very accurate.
That's right.
Very accurate, very descriptive. So then we start to look at how complex this gets as it gets out, and we start to look at what we're really trying to drive as we bring all this together. At the end of the day, the one key thing you want to be thinking about with this slide is the purpose or the intent of that network. Whether it is an intent network or not, it's to deliver that appropriate digital experience to the users and things that are utilizing that network, whether that's employee digital experience or customer digital experience. And we have to be deploying that and thinking about it from a management and administration perspective across the internet. Because IT is no longer delivered from a series of in-house resources sitting in on-premises data centers. It's delivered from those and a series of software as a service, infrastructure as a service, and other services delivered across the cloud to users that are globally distributed across different devices.
I have never heard so much BS in my life. This is saying it all.
And the truth comes out, and the truth comes out. I can't wait to see you, Justin. This is, oh yeah.
You hit 0 of it. There was 0 of the point of this slide that was covered in that babble.
Exactly. Yeah, that was really bad. Really, really bad.
Good to know. Good to know. My confidence is on a high for this next surprise. So as we look at this, the thing to really think through is that the pace of change is increasing. As we start to look at where IT moves, we're moving faster every day in how fast we have to change to enable our businesses, and the competition amongst businesses is getting stronger. Technology has shifted from that cost center where we're focused on full perspective of return on investment or cost savings to business enablement. The faster we can move our technology, the faster the business can move, driving its mission or revenue, depending on which type of business it may be.
Nice. That was a good job. Missed on a couple of slides, but it was pretty good.
I don't know, Justin. I think you're being too nice. You're being too nice, you know?
Yeah. Well, you know, I got to take Joe into account. It is Joe, right? You got to kid gloves. Come on.
We're grading on a curve now. Is that what we're doing here?
We are grading on a curve. Yes.
So Sabrina, at a 1 out of 10, did I get a 10 or did I get like a 9.87?
You know, I knew. I'm just going to give an estimate here or a guess of how Justin's going to do comparatively. I know he's going to knock it out of the park. I think we saw a lot of your best BSing skills, so I'll give you that. You did not bring an A game background, so you're already in negative points for that. I see no Jurassic Park, no 3D in any way. So that was a major disappointment right off the bat. So 1 to 10, I'd give you an eh. Probably an eh. It's as good as it gets today, Joe. As good as it gets.
That's sadly very standard for me. Excellent. Well, Justin, I think the bar is set nice and low. It is time for you to take this away and show us what this looks like. And I'd like to learn a little bit about digital network architecture of the process.
So thanks. We are going to talk about digital network architecture and what it is. And Joe, you were pretty close. I mean, for a lot of these, really what we want to talk about is, instead of doing networking the way we've done it before, which was source and destination, it was IP based. We want to make a shift. Think about what we're working with today. We have 20-year-old protocols. Think about how old IP, spanning tree, VLANs, all that stuff that we're typically used to as legacy network guys, in understanding that that's 20 plus years old, and we're running modern apps, expecting some cool stuff to happen. So really what needed to happen was a shift in the way we do networking. And this is intent-based networking. And you were right. We had your intent comes in, right? So what is the intent? My intent is to access email. So in this case, my intent comes in, I get applied a security policy based on my intent. It doesn't have to be a security policy. It can be a QoS policy. It can be any kind of policy. But I want to sit there and look at the context of that. Is it really doing what I need it to do? And then I'm going to watch that. We get to the top of this and I'm learning. So then now my intent changes. So I place a phone call. And now when I'm placing this phone call, I went from a data-only transaction with no QoS to a mission-critical application. So my intent has changed. So I want to provide policy based on that intent change. I want to sit there and look at the context of that, making sure it's doing what it's supposed to be doing, or my SLA is okay, and all that stuff. Sits there and learning. Now I hang up the phone call, and my intent has changed back to a data-only transaction. This is really the premise behind intent-based networking, right? That's far different than, you know, VLANs and IP addresses. I want as a user just to manage my network based on who I am and what I'm trying to get to and what my intent is. If my intent is malicious, I want to provide policy to stop that. So how does that happen? How do I get my intent onto the network? And Joe, again, you were right here, where basically my intent comes in, and what happens is everything you're seeing in blue here is what DNA Center is doing. It's taking my intent and it's making that a policy that the network can understand. Because how do I say Justin's intent is to check his email? It's a data-only transaction that doesn't need a QoS. How do I communicate that, right? And that's really what DNA Center is doing. Is it's taking that policy that I'm building, it's translating that and automating it and pushing it down to the network. So once the network goes, oh, now I get it. Now I understand what Justin's intent is. We can go start look at the context of that transaction and gather those analytics. So DNAC will take the context coming from the network in green there and translate that into analytics and assurance so I can actually monitor and see what's going on. Again, this could be all of our careers at any point in time once the machines take over. So just keep that in mind.
It's on its way.
It is on its way, and actually in a good way, because what we'll see here is, and what we'll see later is why things kind of need to change and why we need to adjust as a network professional. But this slide was really depicting what software-defined access is. It's kind of a confusing topic to understand. Is what is software-defined access? It's pretty straightforward. Joe did a really good job of breaking down the three different pillars here, but really what software-defined access is: policy and segmentation, it's automation, and it's insights and telemetry. Those are the three things that actually make up software-defined access. You remove one of those, you don't really have software-defined access at that point. And again, part of software-defined access is making sure that we have the policy that follows us. So what we saw was making sure that when I log into the network and I'm allowed to talk to other employees, I get to that resource, but I'm not getting to stuff I don't need to get to PCI, for example, like the PCI server. What's really powerful about this that Joe didn't mention, shockingly, that Joe didn't mention this, is the fact that regardless of where I'm at or what I'm logging into, this policy follows me. So think about how powerful that is, right? When I have 50 different branches, that's 50 different policies, 50 different access lists, 50 different things I have to touch at that point in time. This is one policy that follows me regardless of whether I'm working from Starbucks, I'm working from a branch, I'm working from home. It follows me whether I'm wired or wireless. And more importantly, especially because of the pandemic, we had to make a rush and get out of the office. We had people working from cell phones, from BYOD. That policy follows me regardless of what I log into. So no matter where I'm at, no matter what I log into, this policy is going to make sure that it follows me, that I can't get to stuff that I shouldn't be getting to. And the one that Joe got wrong here, which really all this is depicting is what an overlay is. So software-defined infrastructure, software-defined X, is really about overlays. It's abstracting the software from the hardware. So what's really great about all of these new digital solutions against digital network architecture, right? We have software-defined access, which is LAN. We have software-defined WAN, which is in the WAN, obviously. Then we have ACI, which is software-defined data center. All of those are overlays, meaning we're abstracting the features from the hardware or the software from the hardware. So if you think about in the past, Cisco had something called TrustSec, right? It wasn't widely adopted because everything from point A to point B had to support those features. In this new digital network architecture, that's no longer the case. We can actually do a lot of cool things without the underlay network supporting the features because it's overlays. So if you're not familiar with an overlay, think of GRE, IPsec, MPLS, CAPWAP, right? Those are all things that are tunneled through our network where each node along the way doesn't have to actually support what's going on as long as that overlay supports it. In the fabric, so ultimately, what is software-defined access? What does that look like? It's a fabric. And these are the different nodes within the fabric. So you got some of the things, right, around the DNA controller really being the brains. And honestly, from a next generation network, whether it's WAN, whether it's data center, whether it's software defined, they all have a controller. The controller is the brain of what's going on. So we're taking away the individual pieces and parts. So having to touch each access point, it making its own decision, every router making its own decision, switch making its own decision. And we're going to move that to something that's a little bit smarter, that has AI analytics, automation. That's the stuff that the routers and the switches and the access points could never support. So we had to move that functionality to something was smarter, which was a controller. So every software-defined solution has some form of controller or brains. The rest of them are different nodes within the fabric. We're so used to that three-tiered fabric, or the three-tiered network, right? Access, distribution, and core. Really what we want to do is start looking at as fabric border nodes, control plane nodes, fabric edge nodes. Fabric edge nodes being our entry and exit onto this fabric. Our border nodes being the things that once we leave the fabric and we still need to maintain policy, how does that work, right? So it's identifying that, hey, I'm leaving this fabric and I'm going to apply policy based on that. Control plane nodes are part of the brains in behind this. Although that DNAC is really the brains, the control plane nodes is really tracking where users are at and reporting that up to DNA Center. And then obviously the power behind all of this is the fact that, again, it's an overlay. We have intermediate nodes that are underneath the fabric. They don't have to support anything that we're doing here. They just need to be able to go transport from point A to point B, so some basic routing. And then lastly, this whiteboard is absolutely great if you want to talk about Thousand Eyes and visibility. I can't even start to talk about what this is actually explaining. I just threw this in there because I knew Joe probably would make something up and I wanted to see what he actually would make up. Although it did sound pretty good, that's really not what this is depicting. This is depicting Thousand Eyes, which is a Cisco acquisition, being able to really look inside all the different clouds, looking inside our service providers, being able to give us advanced visibility. So we talked about insights and analytics with DNA Center. Now imagine taking that up a notch and looking at what's going on in our service provider. So a good example of this is I do stuff like this all the time from my home. My coworkers were saying my audio sucks. So what I did was I installed a Thousand Eyes agent on my laptop. I found out that the repeater in my neighborhood was dropping 10% of my packets, right? So ultimately what I was able to do was export that, send it to the service provider, in this case Comcast, and they came out and said, yep, the repeater's going bad, you were right. And they had it fixed the next day. As we move to a hybrid workforce in these digital network infrastructures, we really need to start to look at the assurance and our visibility into the things, especially from a remote worker and a customer experience and employee experience. Thousand Eyes is really good at giving us insight and visibility into that. So really, with all that being said, network is in the process of making a change. We've always had software-defined data center for a while now. We've had software-defined WAN for a while now. Network was kind of lagging behind. That's software-defined access. So really what we're doing is we're starting to see this shift into this digital network architecture. Some of you might see DNA licensing. That's the beginning of that. But it really ties into the whole solution from all the way from endpoint all the way into the data center on how all this works.
Wow.
I definitely will give Joe more credit than than Sabrina you gave him. That's for sure. But
I think I'm just the more realistic one, but that's fine, you know. Especially at the end there. Gosh, Joe, you must be humiliated. Justin, that was brilliant. That last slide, not the closer, but the whiteboard was an absolute mic drop. I love how you brought it back to what businesses are actually facing now. I think sometimes we forget that we're kind of still going through the pandemic and there's still a lot of employees there were a lot of Band-Aids out there. No, I thought that was just, like I said, and then that last slide, you really just, gosh, Joe, I'm so sorry. I'm so sorry you had to go through this publicly, but here we are, here we are.
It happens. Most of my humiliations are public. So I'm actually very used to it. I've got kind of like the scar tissue to protect me from it. But I think, Justin, you hit on two really, really key points that I dropped the ball on completely. I think the first is that the first was the overlay, but also tied in with the controller. So we're using those two things together to move from configuration management on a bunch of semi-intelligent routers and switches to an intelligent controller that can direct everything from a higher level. And then the overlays are allowing us to utilize those routers and switches really just to provide a routed fabric which intelligence can be overlaid onto by that controller. Is that
exactly
fair?
That's exactly what's going on. Yep.
Okay. And so the overlay there just becomes fairly arbitrary, right? If the controller can work with the overlay and you've got a routed fabric, the overlay is fairly interchangeable based on the solution you're looking at.
Exactly. I could use an overlay for my career, man. That would be great. Go from network guy to CEO. Let's overlay it, right?
Just overlay right on there, right? Abstract at a level, right? I wish that worked. I wish that worked in real life.
Indeed.
Excellent. Well, that was good. I think I definitely learned something about that overall solution, and definitely with Thousand Eyes. I was just thinking, I might have to buy Thousand Eyes now because I live in a very rural area now, and so I have a very rural ISP, and they have a lot of rural ISP problems that I could probably fix for myself.
Yep. And the worst thing about that is it's always like, let me loop your cable modem. Yep, it's working fine, right? And they're like, well, the problem's on your end.
That's exactly it.
Yep.
That's exactly
Every
it.
time. Every conversation with them is the same. So it's definitely, visibility is definitely a key in a next generation network that every organization should look at.
Sure, they love having you as a customer. I can only imagine,
Oh yeah. We've had, did you reboot it? Yes. Any question the first 10 questions you're going to ask me, the answer is yes. So can we get
I probably help write them for Comcast.
Yeah.
Visibility is so critical. And I don't know if everyone in the audience really understands how lacking traditional networks were in visibility. Like if you're troubleshooting a problem, you can go to a given switch and see what that switch sees. So you can see its routed peers, you can see attached devices based on typically hardware addressing, MAC addresses and the assigned IPs. But getting beyond that to really see what's happening, especially at a global scale, has always been really limited in the network itself. So increasing that, especially as we automate and we change faster and we attach more devices, is absolutely critical. So a great point.
Very much so. Yep.
Yeah.
Mm-hmm. Well, Sabrina, I mean, I have to ask because it's official, but obviously I did a better presentation, right?
It was neck and neck there, Joe, for a second, just for a second. Now I have to give this one to Justin. No doubt about that. Justin, nicely done. It's so great to have you on. This whole time I've had a hard time looking at you without smiling with the steering wheel. I can't tell you the amount of just joy that brought to my heart. Oh, it's so...
I'm ready to drive off. And hey, you can't give Joe too hard of a time, right? He's young. He needs the money.
He needs the money. Yeah. He's handling on the weekends. It's tough. It's a tough life out there. Exactly. You had the ship, the shipwreck. You saw what his career has gone to. Yeah.
That's right. It's a warning for all of us, people. It's a warning for all of us.
That's what I'm here for. That's what I'm here for, to serve as a warning to others.
Yeah.
Cautionary tale, if you will. That's right. Justin, where can people find you if they have more questions or just want to give you, general haze, anything like that?
jallen at ePlus.com. Jallen, pretty simple and straightforward on LinkedIn as well.
Brilliant. Well, Justin, this was a pleasure. I've been looking forward to this episode for quite a while. It is, it's fun to have you on. I love the content, and thanks for putting up with us.
Thank you. I appreciate it.